Good morning, dear students. Today we are going to discuss about the concept of equivalent mass. Equivalent mass of a substance equal to molar mass divided by n factor. If you want to calculate the equivalent mass of an element, the equation will be equivalent mass of an element equal to atomic mass divided by valency. Here n factor will be equal to valency. What do you mean by valency? The valency of an element is a measure of its capacity to combine with the other elements to form compounds. More simply, we can say that the number of atoms of hydrogen with which one atom of an element will combine is called the valency of the element. For example, fluorine, oxygen, nitrogen and carbon. These atoms combine with the hydrogen atoms by fluorine combined with the 1 hydrogen atoms. Oxygen combined with the 2 hydrogen atoms. Nitrogen combines with the 3 hydrogen atoms and carbon combined with the 4 hydrogen atoms and correspondingly forms HF, H2O, NH3 and CH4 respectively. So, here the valency of fluorine is 1. Valency of oxygen is 2. Valency of nitrogen is 3 and valency of carbon is 4. That is the number of atoms of hydrogen with which one atom of an element will combine is called the valency of the element. That is the earlier concept about the valency. In the case of elements which do not combine with the hydrogen, their combining capacity or their valency with elements having established valencies were considered to determine their own valencies. In general, the maximum number of univalent atoms that may combine with an atom of the element under consideration can be regarded as its valency. And the valency of an element is always an integer. It does not carry a plus or minus sign. In the case of covalent compounds, the valency can be described the number of bonds usually formed by each element. For example, fluorine generally form one covalent bond in their compounds. So they are said to be univalent or monovalent. In the case of oxygen, it will form two covalent bonds in their compound. So they are said to be divalent. In the case of nitrogen, it will form three covalent bonds in their compounds and they said to be trivalent. And in the case of carbon, it will form four covalent bonds in their compounds and they are said to be tetravalent respectively. Then in the case of ionic compounds, the number of positive or negative charges that appear on the atom in its ion helps to state its valency. For example, sodium form Na plus compounds. So its valency will obviously 1. In the case of magnesium, it will form magnesium Mg2 plus compounds. So its valency is 2. Whereas in the case of aluminium, it will form Al3 plus compounds. So obviously its valency will be 3. Another possibility of an element having more than one valency in its compounds, that is called variable valency. For example, in the case of ferrous compounds, it shows two valency. That is, one is ferrous compounds, another one is ferric compounds. In case of ferrous compounds, its valency of iron is 2 And in the case of ferric compounds, the valency of iron is 3. Such a compounds are said to have variable valency. That's about valency of an element. Then consider the case of equivalent mass of an acid. The N factor will be the number of H plus ions, that is basicity. Then what will be the equation of equivalent mass of an acid? Equal to molar mass divided by basicity. So in the case of acids, the number of replaceable or ionizable hydrogen atoms present per molecule is determined the value of N factor. Then if you want to calculate the equivalent mass of a base, then the equation will be molar mass divided by acidity. That is the number of hydrogen ions with which one molecule of a base reacts is called its acidity. That is number of hydroxyl ions, that is number of OH minus ions furnished by one molecule of a base in aqueous solution is determined N factor for a base. Then if we want to calculate the equivalent mass of a salt, then N factor will be equal to number of electrons transferred. That is molar mass divided by number of electrons transferred per molecule. That is the case of equivalent mass of a salt. If we calculate the equivalent mass of an oxidizing agent or an oxidant, equation will be molar mass divided by number of electrons gained per molecule. And equivalent mass of an reducing agent or equivalent mass of a reductant will be equal to molar mass divided by number of electrons furnished per molecule. Let us consider the problems based on calculation of equivalent mass. First, we have to calculate the equivalent mass of an element. Here first, in the case of aluminium, what will be its equivalent mass? We know that atomic mass of aluminium equal to 27. Then what is the equation for equivalent mass? Equivalent mass of an element equal to atomic mass divided by its valency. And we know that aluminium shows a valency of 3. Valency equal to 3. Then equivalent mass of an element will be 27 divided by 3, which is equal to 9. Then equivalent mass of an aluminium equal to 9. Already mentioned the case of variable valency showing elements. For example, in the case of copper has atomic mass 63.54. In the case of cuprous compounds, its valency is 1. In the case of cuprous, Cu plus, that is cuprous compounds, valency is 1. Then what will be its equivalent mass? Equivalent mass will be 63.54 divided by 1. That is equal to 63.54. So in the case of cuprous compounds, the equivalent mass of copper is 63.54. Whereas in the case of cupric compounds, its valency is 2. Cu 2 plus. Valency is 2. Then equivalent mass will be 63.54 divided by 2, which is equal to 31.77. So copper has 2 equivalent mass. In the case of cuprous states, its equivalent mass is 63.54, whereas in the case of cupric state, its equivalent mass is 31.77. If we express equivalent mass in grams, that is called gram equivalent mass. That is GEM, gram equivalent mass. If gram equivalent mass is expressed in grams, that is called gram equivalent mass. Then gram equivalent mass of copper in cuprous state is 63.54 gram. Whereas in cupric state, equivalent mass, gram equivalent mass of copper is 31.77 gram. The quantity can be expressed in grams, that is called gram equivalent mass or 1 gram equivalent, or simply it is called 1 equivalent of the substance. That's about equivalent mass of an element. Next we have to find out the equivalent mass of different classes of compounds. Let us consider 3 elements or 3 atoms as a standard. That is hydrogen, oxygen and chlorine. Why we select these 3 elements as a standard one? Because all other compounds react with either hydrogen or oxygen or chlorine. That's why we select these 3 elements as a standard one or reference one. These 3 standard elements react so many other elements in our periodic table. That is hydrogen, oxygen and chlorine. Then atomic mass of hydrogen is 1, oxygen is 16, chlorine 35.45. Then valency of hydrogen is 1, oxygen 2, chlorine again 1. Then how can you calculate equivalent mass? Equivalent mass of an element equal to atomic mass divided by valency. So 1 by 1 equal to 1. 16 by 2 that is equal to 8. 35.45 divided by 1 that is equal to 35.45. So this is equivalent mass of hydrogen, or 1 equivalent of hydrogen is 1. And 1 equivalent of oxygen is 8 and 1 equivalent of chlorine is 35.45. In the case of aluminium, here 1 equivalent of aluminium is 9. It is fixed because its valency is a constant, that is 3. Whereas in the case of copper, its 1 equivalent is 63.54 in the case of cuprous state and 31.77 in the case of cupric state. And gram equivalent mass of hydrogen is 1 gram and gram equivalent mass of oxygen is 8 gram and gram equivalent mass of chlorine is 35.45 gram. Then equivalent mass of all other compounds can be calculated using these standard values, that is this hydrogen, oxygen and chlorine values. Consider this is a vessel contain a compound called X. We have to calculate its equivalent mass. If this compound reacts with one of these standard, for example hydrogen, so here it reacts with hydrogen, it will convert it into a compound HX. We have to find out the equivalent mass of X in this compound HX. When we analyze this compound, consider 8 gram of hydrogen requires 40 gram X, which means 8 gram of hydrogen reacts with the 40 gram of X in this compound. We know that equivalent mass of hydrogen is 1 unit, or gram equivalent mass GEM of hydrogen is 1 gram, equal to 1 gram. So 8 gram hydrogen means 8 equivalent of hydrogen. 1 gram hydrogen means 1 equivalent of hydrogen. That is 8 gram of hydrogen means 8 equivalent of hydrogen. Here 8 equivalent of hydrogen requires 40 gram of X. We want to know 1 gram equivalent of hydrogen requires how many grams of X. How can you calculate? That is 1 gram hydrogen requires 40 divided by 8 gram X. That is equal to 5 gram X. Which means 1 gram hydrogen requires 5 gram of X, or 1 equivalent of hydrogen requires 5 gram of X. Or we can write 1 equivalent of hydrogen requires 5 gram of X, or simply we can write 5 gram of X means 5, that is the equivalent mass of X. Here 1 part of hydrogen requires how many part of X? That is 5 part of X. That is called our equivalent mass. Another example, this is our unknown compound Y in a vessel. Its equivalent mass is have to calculate. Then when it reacts with another standard, that is our oxygen, it will convert it into a compound OY. On analysis of this compound OY, it was found that 32 gram of oxygen requires 100 gram Y. We know that equivalent mass of oxygen is 8 gram. Gram equivalent mass of oxygen is 8 gram. Then 8 gram oxygen requires 100 divided by 32 into 8. So here 8 gram of oxygen requires 25 gram of Y. We know that equivalent weight of oxygen is 8 gram, or 1 equivalent of oxygen is 8 gram. Then 1 equivalent of oxygen requires 25 gram of Y, which means gram equivalent mass of Y is 25 gram. Or simply we can say that 8 parts of oxygen reacts with how many parts of Y? 25 parts of Y. That is the equivalent mass of Y, or that is the 1 equivalent of Y. Similarly, we can work out with the chlorine. Then how can you define equivalent mass? Equivalent mass of an element is defined as a number which expresses the number of parts by mass of that element which combines with or displaces 1 part by mass of hydrogen, or 8 parts by mass of oxygen, or 35.45 parts by mass of chlorine, or 1 equivalent mass of any other element. Okay, now calculation of equivalent mass of an acid. Calculate the equivalent mass of HCl. We know that HCl is a monobasic acid. So its equivalent mass equal to molecular mass divided by basicity. Here basicity equal to 1. So 36.45 divided by 1, that is equal to 36.45. Whereas in the case of sulfuric acid, H2SO4, what is the equivalent mass? Molecular mass is 98. 98 divided by its basicity. Basicity is 2. There is 2 replaceable hydrogen. So basicity equal to 2. So we can get 49 is the equivalent mass of sulfuric acid. Then now we have to calculate the equivalent mass of a base like sodium hydroxide. What is the equation? Molecular mass divided by acidity. Sodium hydroxide is a monoacidic base. So its equivalent mass is molecular mass divided by acidity. Here acidity is 1. So we can calculate 40 as the equivalent mass of sodium hydroxide. Then calculate the equivalent mass of calcium hydroxide, which is a diacidic acid. So its equivalent mass is molecular mass divided by acidity. Here acidity is 2. There is 2 replaceable hydrogen and we get 37 as the equivalent mass of calcium hydroxide. Consider an oxidizing action. The oxidizing action of KMnO4. Here 158 gram of KMnO4 gained by 5 mole of electrons. Then what will be the equivalent mass of an oxidizing agent? We know that KMnO4 is an oxidizing agent. Then equivalent mass of an oxidant will be equal to molecular mass divided by number of electrons gained per molecule. Then equivalent mass of KMnO4 equal to 158 divided by 5. Here 5 electrons accepted. So 158 divided by 5, that is 31.6. 31.6 gram. So gram equivalent mass of KMnO4 is 31.6. Then consider a reducing reaction, reducing action of ferrous sulfate. Here 151.85 gram of ferrous sulfate reacts and 1 mole of electrons furnished per molecule. Then what will be the equivalent mass of ferrous sulfate? That is molecular mass divided by number of electrons furnished per molecule. That is 151.85 divided by 1. That is equal to 151.85 gram. So gram equivalent mass of ferrous sulfate is 151.85 gram. Next is methods of expressing concentration of a solution. We have different methods for expressing concentration of a solution, that is molarity, normality, molality, mole fraction, etc. First one, molarity. Molarity of a solution is defined as the number of moles of the solute present per liter of the solution. That is molarity equal to number of moles of the solute divided by volume of the solution in liters. If the number of moles of a solute present in V liter, that is the volume of its solution, is N2. Number of moles is N2. Then the molarity of the solution, that can be represented by capital letter M. M is equal to N2 divided by V. Then if the mass of the solute of molecular mass M2 present in V liter of the solution is W2 gram. Mass of the solute is W2. Then the molarity of the solution M equal to W2 divided by M2 into V. Here W2 divided by M2 is the number of moles of the solute. Next method is normality. Normality of a solution is defined as the number of gram equivalents of the solute present per liter of the solution. That is normality equal to number of gram equivalents of the solute divided by volume of the solution in liter. If the number of moles of the solute present in V, that is the volume of the solution, number of moles is N2 dash. Then the normality of the solution that can be represented by capital letter N equal to N2 dash divided by V. Then N2 dash. How can you calculate N2 dash, number of moles? If the mass of the solute of equivalent mass E2, equivalent mass is E2, present in volume V liter of the solution is W2, mass is W2 gram. Then the normality of the solution N is equal to W2 divided by E2, mass divided by equivalent mass into volume. That is the equation for normality. Here W2 divided by E2 is the number of moles of the solute. Not number of moles, number of gram equivalents of the solute. Next term is molarity. Molarity of a solution is defined as the number of moles of the solute present per 1 kilogram of the solvent. So, molality is equal to number of moles of the solute divided by mass in kilogram of the solvent. If it is present in gram, then we can write number of moles of the solute divided by mass in gram of the solvent into 1000. Then if the number of moles of a solute present in W1 gram of a solvent is N2. Here number of moles N2 present in W1 gram. Then the molality. Molality can be represented by small letter m, where capital letter M designated as molarity. Then molality, small letter m is equal to N2 divided by W1 into 1000. And if a solution is prepared by dissolving W2 gram of a solute, W2 gram of a solute of molecular mass M2 in W1 gram of a solvent, then molality M of the solution will be equal to W2 into 1000 divided by M2 into W1. Here W2 divided by M2 equal to number of moles. Next term is mole fraction. Mole fraction of any component of a solution is defined as the ratio of the number of moles of that component to the total number of moles of the solution. If N1 and N2 be the respective number of moles, N1 and N2 of the solvent and solute in a binary solution, then mole fraction of the solvent, equal to N1 divided by N1 plus N2. Mole fraction of the solute, X2 is equal to N2 divided by N1 plus N2, where N1 is the number of moles of the solvent, N2 is the number of moles of the solute. X2 is the mole fraction of the solute and X1 is the mole fraction of the solvent. Here X1 plus X2, mole fraction of the solvent and mole fraction of the solute will be equal to 1. Next is the temperature dependence of these terms. Here the first two terms, that is molarity and normality of a solution, change with the temperature because they depend upon the volume of the solution, which changes with the change in temperature. Whereas the last two terms, that is molality and mole fraction, do not depend upon the volume of the solution. Here we know that the calculation of these two terms involves number of moles of components only, which do not change with the change in temperature. Hence, values of these concentration terms for a solution do not change with the temperature. Next is the calculation of concentration after dilution of a solution of non-concentration. In analytical chemistry experiments, we normally prepare a concentrated stock solution first and then dilute into a non-volume by adding required amount of solvent. Suppose a given volume V1 liter of a stock solution of molarity M1 is diluted to a new volume V2 liter. Only the concentration of the solution changes. The amount of solute present in it does not change. In other words, the molarity of a solution changes from M1 to M2 after dilution. So, we can calculate the molarity M2 by using dilution equation, that is M1 V1 equal to M2 V2. Knowing M1 and V1 and V2, that will be a non-volume, we can calculate the value of M2 or vice versa. And if concentrations are considered in terms of normality, then the corresponding dilution equation will be N1V1 equal to N2V2. Here N1, N2 respectively represent the normality values before and after dilution. Hope it is clear. Thank you.